and good day, geometry. We have reached our final part of simplifying radical expressions, which means that after this we get to do stuff with them. We're gonna add them, and we're gonna multiply and subtract and divide and solve. But right now we're still kind of simplifying, and it's this objective where this probably isn't. I don't think it's an introduction. This dead air brought to you by. I don't think it's an introduction to other degreed radicals, but this is the reason why on the 5-card challenge you have to have a 2 to use a square root, because even though we don't write it because it's kind of the standard root, there's technically a 2 when you take the square root of 16, okay? Because there are other degrees of roots that exist. For example, the cubed root of 8. Those of you that have experience with other degrees of roots, what does the cubed root of 8 mean? Caleb.
Would that just mean like if you broke it equally into 3 parts?
Right. So just like how a square root means what number times itself, or what number squared, equals 16, the cubed root of 8 means what number times itself, or what number cubed, right, equals 8. That's kind of how you can think about that. And what would that number be? What number, Gino?
2.
Right. 2 times 2 times 2 is 8. 2 cubed equals 8. So the cubed root of 8 would be 2. Okay. How about the 4th root of 81? This is saying what number to the 4th power equals 81, or what times itself times itself times itself equals 81. What do you think, Drake? 3 is correct. Okay, 3 to the 4th is 81, and 3 times 3 times 3 times 3. So again, those of you that have scoffed at needing the 2 for that square root in the 5-card challenge, because you can use other degrees of roots, cubed roots, 4th roots, etc. If you're going to use a square root, it just would make sense that you'd need to have the 2 there. The cubed root of 64. What number cubed is 64? Or what times what times what? Or what times itself, I should say. Adam? 4. Yeah. 4 cubed equals 64. So 4 is the answer. The 8th root of 1. Caleb?
Is it 1?
Gino, is that what you're going to say?
Yeah.
Good. Yes, it is 1. Okay. It is 1. This is how, speaking of Aiden, there's one 5-card challenge where he got over 1,000 points. Just because I said he wouldn't be able to do it, so he just did a spite. No, different Aiden. But what he did was the 6th card. So here are your 5 cards. The 6th card was a 1, and one of the cards you had up above here was a 1 also. So he just did various combinations of all sorts of different degrees of roots using those other 4 cards to get that of 1 to equal a 1. And so I said he couldn't get 1,000 points. He proved me wrong. He got over 1,000 points. But that's the magic combo there. If you ever, yeah, totally. But he will be well off for the rest of his life because of it. So, yes. I don't think I gave him one.
You got 1,000 points.
That's just like no motivation.
Probably just waiting at it.
Come on, give us. Okay, what if you get over 100?
Ooh.
You should.
Maybe you could like change the color of this thing, like a gold one.
Maybe.
$1,000 for every single point you got one. Give him 1,000 total.
Yeah. Knowing him, I think just the fact that he proved me wrong was reward enough, but I don't know. Okay, anyway, the 5th root of 100,000, what number to the 5th power, or what times itself, times itself, times itself, times itself, Drake? It would equal 10. Okay, so it's this background knowledge that you need for the crux of today's lesson, which is what happens when you have a fractional power. Yeah, right? Exponents can be fractions. Isn't that exciting? Okay. Here is what I recommend you put it on your help sheet, okay? Because what this little formula does is it tells you where the base goes in putting an exponent written into root form. That base of n becomes the what's under the root. The numerator of your fraction becomes the exponents, boys, to the expression, and the denominator of that fraction becomes the degree of the root. So those people that like to fight me on PERMDAS, their biggest argument, and it's not wrong, what they say is that the root of 16 can be written as 16 to the 1/2 power, right? The root of 16 is equal to 16 to the 1/2 power because the degree of this root, even though we don't write it, is a 2, right? That denominator of that fraction becomes the degree, that y there, okay? And then if we were to put an exponent on this entire thing, what would that exponent be? A 1, right? Which is the numerator of that fraction there. So the argument against PERMDAS is, well, yeah, but you can write an exponent as a root, and you can write a root as an exponent, so they're not really opposites, okay? Of course, my comeback to that is that, well, yeah, but you can also write, division, 8 divided by 2, as 8 times 1/2. I mean, you can write multiplication and division as each other, and no one's going to argue that they're opposites. So I strike it down with that. But anyway, just so you know, the main argument, if someone ever tries to fight you on it, you are going to be my army when you graduate here. Get it? Get it? You're my art. No, John, you can't switch sides. Okay. But when you're given something like 8 to the 2/3, just take a moment and let it kind of sink in. Really, really look at it. What is 8 to the 2/3 asking? Okay. That denominator becomes the degree of the root, and the numerator becomes what we take that total to. So 8 to the 2/3 means we want the cubed root of 8 squared, right? Knowing that the cubed root of 8 is 2, 2 squared ultimately ends up being 4. Another way, I'll get you in a second. Another way to think about it is that if you are asked for 8 to the 2/3, you want to find the cubed root of 8, but you only want 2 of those 3, which would be 4. Okay? So you can kind of think about it in terms of a fraction also. The 8 to the 2/3 power, you want that cubed root of 8, which is 2 times 2 times 2, right? But you only want 2 of them, and that's where our 4 comes from here. Okay? Yes, Caleb?
What? I forgot what it was before PERMDAS. Is it? Oh, it's PEMDAS.
PEMDAS, yeah.
I forgot what it was before PERMDAS.
Yeah, that's good. That means it's becoming so ingrained in your brain.
I couldn't think of it.
Yeah. Okay. So 25 to the 1/2 power. Okay. You can think about this either as rewriting it to be the square root, take that denominator, make it the degree of the root, to the first power. Or you can think about it as, what times itself equals 25, and you want one of them. You want one of the two. Either way, the square root of 25 is 5. That taken to the first power still equals 5. If we write it out with the what times itself, 5 times 5 equals 25. We want one of the two, thus the 1/2, and there we get 5. Okay. 81 to the 3/4 power. You can either write it as the denominator for the degree. The numerator is your exponent on that expression. So 81 to the 3/4 is the 4th root of 81 cubed. Or you can think about it as the 4th root of 81. What times itself, times itself, times itself. And we want 3 of those, right? 3 of the 4. So the 4th root of 81 is 3. 3 cubed equals 27. Or the 4th root of 81, 3 times 3 times 3 times 3, we want 3 of those 4, as our fraction states, and 3 times 3 times 3 is 27. 2 ways to think about it. Okay? Is anybody so lost that they are and willing to admit it that we need to rehash things? Okay? Those of you that like to just memorize stuff, like just give me something to memorize. This here is what you want to memorize. This formula. Where does my n go? Where's my base go? Where's my denominator go? Where's my numerator go? That's the memorization. Those that like to get the why of it, like the number sense part of it, what's actually happening, then you'll prefer probably this here. What number multiplied by itself 4 times is 81? I want 3 of those 4. That's how it works. Yes? Yes, every single time. Even if you have an improper fraction, such as we have in that fourth one there, 27 to the 4 thirds. It's the degree of the root. Yep, always. Always. So if you have an improper fraction like 27 to the 4 thirds, this is still going to be, here's my denominator of 3. That's going to be the root of my 27, and I'm taking that to the 4th power. So the cubed root of 27 is 3. 3 to the 4th power equals 81. Why does it make sense that the answer we get, 81, is larger than the 27 that we started with? Logically, why does that make sense here? Because everything else has been smaller, right? 27 is less than 81, 5 is less. Why does it make sense that for 27 to the 4 thirds power, we'd end up with something greater than what we started with? Gino?
It's because the fraction is
Yeah, it's an improper fraction, right? So since an improper fraction is greater than 1, we're going to get a value that's greater than what we started with, okay? Mathematically here, what's really going on? We still want what number cubed equals 27, which is 3. But now we want 4 of those 3. We want all 3 of them plus an extra one because it's 4 thirds, right? We want all 3 of them plus an extra one. That brings us to 81. Gino?
How do we put them in our calculator?
So to put them in your calculator, you've got the recommended calculator for the course? Okay, so let's just do 32 to the 4 fifths here. You do your 32, and then you do the to the button, that caret, which is right above the x squared key, I believe. Yes? Right? And then in parentheses, you would do 4 divided by 5. And if you do that right, for this one, you should get a 16. Yep. Okay. So your calculator work for this, it's that caret button, and just like if it was to the 7th power, the 10th power, or whatever, so the 4/5 power, you put that 4/5 in parentheses. Yeah. You will. However, for this part of the test, I'm going to say write this expression using a root. So you still need to know how to rewrite it as this, or I'll say, show me how you could find the answer. And if you just type in this, that's just what buttons you push. So for the test, you'll either need to be able to write that for me or write this for me. Be able to explain it one of the 2 ways. That's what I said. For you folks that just like to memorize stuff, then you've got the formulas to memorize. Okay? Where's my x go? Where's my y? Where's my n? For those that like the logic and the reasoning, the math behind it, then that's that second part there. Caleb.
So for the last one, 512, you get like a nasty decimal. This should be the answer. How do you write that?
Okay, so for 512 to the negative 5 thirds, we have a negative power there. Remember we just learned about this. What does a negative exponent mean? What's our rule for a negative power? CO13. Negative exponents. Peter?
Move it over to the other side and put a 1 on top.
Move it to the other part of the fraction. So for this one, and I've got like 30 seconds left here. For this one, it'd be the third root of 512 to the 5th power, which someone who's calculated that, what do you get from that? Is it 8 to the 5th power? The cubed root of 512, is that 8?
Yes.
Okay, and then 8 to the 5th power is what? Oh, geez. I'll take it and do it myself. 8 to the 5th power is 32,768. Okay? Because our exponent was originally negative, our answer is going to be 1 over 32,768. Right? Because you move to the other part of the fraction. Okay? So it was in the numerator becomes the denominator. All right? For homework for Monday, I only want you to do these 10, however many there are, just this section here. Don't worry about the bottom section. Okay? Focus on either just memorizing that formula or the math behind it. You need to know one of those for the test. All right, folks, that's A math.